Hi, in this tutorial I would like to talk about regression and about how to conduct it in R. Regression analysis is when we fit a linear model to our data and use it to predict values of an outcome or dependent variable. We use one or more predictor variables, and depending on the number we differentiate between simple linear regression, which is when we use only one predictor variable, and we have multiple linear regression when we use more predictor variables. In regression, the model we fit is linear, which means that we summarize a dataset with a straight line. We are trying to find the line and to fit a model that will best describe our data. And to do this, we use a mathematical technique which is called the method of least squares to establish the line that best describes this collected data. To demonstrate the regression, we will use the following example. You are a marketing research analyst at a music label, and your task is to suggest a marketing plan for the next year that will result in high product sales. And you have information and data set including the numbers for sales of music downloads in thousands of units and advertising expenditures in thousands of euros. And in the dataset we will have some other variables, but we will not need them for this example, so we don't talk about them now. And in order to demonstrate the simple linear regression, we will try to answer the question if there is a relationship between advertising budget and sales, and if yes, how strong is this relationship. Simple linear regression model equation in general looks like this. And if we wanted to apply the equation in our example, we could write it in the following way. Together, beta 0 and beta 1, which you can see in the equation, represent the model coefficients of our parameters. Beta 0 is the intercept, and it is the number of sales we would expect if no money is spent on advertising. And beta 1 determines the slope of linear line. So it represents the unknown relationship between advertising expenditures and sales. And this number, beta 1, will also tell you by how much sales will increase for an additional euro spent on advertising. And at the end of the equation we have the epsilon sign, which represents the error term. Okay, now when we got a bit of theoretical insights into regression, let's start to do our job in RStudio. Let's load and inspect the data first using the read.table command, and we will assign the data to the regression object. We will run this. Now our data is assigned, and we can check the top 6 rows of our data set by using the command head. You can see we have several variables, but sales and advertising spend will be the most interesting ones for us in this example. So the first two columns. Then we can also use the command describe to display the descriptive statistics for each of the variables. Let's run it. And in the output you can see values such as sample size, mean, standard deviation, median, and so on. We can also display our data in a graph. We will create a scatter plot where we will also display the linear regression line, but first we have to load the library dplyr and ggplot. Now we will create a scatter plot including the regression line by using the ggplot command. We specify the data frame we want to use. In our case, the data frame is regression. Then we specify the aesthetics, so the variables on the axis, we will have the advertising expenses on the x-axis and sales on y-axis. Then we add the dots or the data points by using the geom_point function. Then we add the smooth line using the geom_smooth function. Using the argument method equals to lm, we tell the function to draw the best possible straight line through the data, and then we specify the color and the opacity of the interval, of the confidence interval, by using fill and alpha. And last but not least, we can also add labels using labs function, and we can also specify the theme. Now we run the command, we wait for the scatter plot. Now it's here, and if we look at it we can see that the regression line intersects with the y-axis somewhere between 100 and 150, and this will be our beta 0, so the expected sales level when advertising expenditure is 0. So then we can compare it with our results from the analysis. I would like to shortly mention hypothesis. By conducting regression, we will test the null hypothesis that there is no relationship between advertising and sales, and hence our alternative hypothesis will be that there is some relationship between advertising and sales. You could also write it down in this way. Okay, let's run the regression. In R now we will use the lm function to do this, and we will assign our results to simple regression object. Within the function we first specify the dependent variable, which is sales in our case, then we use tilde sign, and then we specify our independent variable, which is advertising spendings in our case. Then we also specify the data frame where our variables are stored, and we can run the command now. And to view the results we can use the summary function. We can check the results now in the console. So the coefficients in the estimate column, which is here, show our beta 0 and beta 1 values. First we have the intercept, which is 134.14, and remember that we estimated this value from the scatter plot to be somewhere between 100 and 150, and so it's good news that we were right. The coefficient beta 1 in the spend row tells us by how much sales would increase if advertising expenditures are increased by 1 unit, and we could interpret the result that for every extra euro spent on advertising, sales can be expected to increase by 0.096 units. And since our units of measurement were thousands of euros and thousands of albums sold, we can also say that with an increase of advertising expenditures by 1000 euros, our sales will increase by 96 albums. The beta 0 and beta 1 coefficients represent only point estimates. In order to get a better idea of the range of values that the coefficients could take, it is helpful to compute confidence intervals. And we can easily do this in R using the confint function up here. So let's run the function. Now we can see the results here, and for instance, for our model, the 95% confidence interval for beta 0 is 119.28 and 149, and we can conclude that when we do not spend any money on advertising, sales will be somewhere between 119 and 149 units on average. And for increase in advertising expenditures by 1 euro, there will be an average increase in sales of between 0.08 and 0.12. Let's go back to the output from the regression. In the last column, PR or probability, we have the p-values, and we can see that p-value of advertising expenditures is lower than 0.05, and therefore we can reject the null hypothesis and conclude that the advertising budget makes a significant contribution to predicting album sales. Then we also have the multiple R-squared and adjusted R-squared values in the output, and these two values help us to assess the model fit. The multiple R-squared value represents the proportion of variance that is explained by the model, and the value of 0 signifies very bad fit and value of 1 signifies very good fit. The adjusted R-squared indicates the loss of predictive power or shrinkage. We can say that it contains kind of a penalty for including unnecessary variables, and it's very good for comparing different models. The value of R-squared of 0.33 tells us that advertising expenditure accounts for 33% of the variation in album sales. So there are many factors that can explain this variation in sales of different albums, but our model and the advertising expenditures can only explain 33% of this variation. After fitting the model, we can use the estimated coefficients to predict sales for different values of advertising. Let's suppose that we want to predict sales for a new product and the company plans to spend 800 euros on advertising. So how much will the company sell then? We can easily compute this in the following way by the following equation. So just putting the coefficients there and the expected advertising expenditures, but we can also calculate this easily in R. We can specify the intercept from the simple regression object and then the slope, which is multiplied by 800 euros, which the company wants to spend on advertising. And if we run the command, we can see that the predicted value of the dependent variable is 211 units. So we can say that if company invests 800 euros in advertising, the product will on average sell 211 units. That's it for the simple linear regression. Thank you for watching the tutorial.